Hi everyone, this video is about 9702 AS Physics, dealing with past paper questions from section 1.1 and 1.2. Okay, 1.1 deals with physical quantities and estimation. We all know physical quantity is a number with a unit, example 10 kilogram, 5 centimeters, 6 microseconds, and so on. There are some quantities which you'll come across like efficiency. It is not a physical quantity, it is just a comparison ratio between output and input. It could be energy, power, whatever it is. And refractive index is just a constant. It is also not having any unit. Okay, so be careful. Whenever the question asks you about physical quantity, it should have a number with a unit. Estimation. Before doing these estimation questions, just have some rough idea from your question paper. Just take these values. Yeah, here I have given 4 examples, like a volume of a person is 7.5 times 10 to the power of minus 2 meter cube. So you will have a rough idea for an average person. It should be in the order of 10 to the power of minus 2 meter cube. A diameter of a thin wire should be in the order of 10 to the power of minus 3. The cross-sectional area of a wire should be in the order of 10 to the power of minus 7 meters square. Here, the last example is dealing with the mass of the ball, which is asking about a tennis ball. Okay, the question is about tennis ball. So here, the mass of the tennis ball is 0.40 kilogram. So whenever you see the question paper, you also have a note of these things in your notebook. So it would be easy for you whenever you're dealing with estimation questions. Section 1.2 deals with base quantities and derivation of the derived quantities using base quantities, also checking the homogeneity of physical equations. And the last one is prefixes and their symbols. So here, before dealing the questions, you need to have an idea about physical quantity. You need to have an idea about estimation. You need to have this table in your mind. Okay, memorize this table and be careful whenever you're doing this symbol in full form or in unit form. In full form, everything is in simple word. But when you are representing in simple form, be careful. The ampere is in the form of capital letter A and temperature is K, which is capital letter. The rest of the units are in simple letters. Okay. So we only have 7 base quantities. Keep that in mind. The next table, what you need is the prefixes and their symbols. Prefix is the maximum value what A level starts with is tera, and the minimum value what we have is pico. So questions will be coming from tera to pico. Okay, so tera is 10 to the power of 12, giga 10 to the power of 9, mega 10 to the power of 6, kilo is 10 to the power of 3, centi is 10 to the power of minus 2, milli is 10 to the power of minus 3, micro is 10 to the power of minus 6, nano is 10 to the power of minus 9, pico is 10 to the power of minus 12. And again, students get confused with the alphabets, okay? Capital M represents mega, 10 to the power of 6. The small m represents milli, 10 to the power of minus 3. Okay, the next one. Okay, we are getting into the questions. Which row shows a physical quantity and its base unit in the SI system? Okay, so it must be a physical quantity. It must be a base unit with the SI system. Okay, the unit should represent the SI system. So here, obviously, it is A. Am I right? Okay. Yeah. Current, ampere. Okay. So you need to have this table in your mind. This table. Okay. Recall this and check once again everything. So here ampere. Force is in SI unit, like Newton, but Newton is not, the force or the Newton is not in the base system. Mass is in kilogram. Mass must be in kilogram, but it is given in gram. Temperature must be in Kelvin, but it is given in degrees Celsius. Okay. So A is the right option. Okay. A is the right option. Okay. The next one. What is equal to how many zeros? So let us shift this decimal point. 1, 2, 3, 4, 5, 6, which can be written as 5.0 times 10 to the power of minus 6 joules. 10 to the power of minus 6 is nothing but micro. Okay, so it is mu. Okay. What represents a physical quantity? Remember, physical quantity means it must have a number with a unit. A number with a unit is the option C. The rest do not have it. The first one do not have a unit, no number. Okay, so then the last one is just a percentage, so it is not a physical quantity. The next question, which unit is not an SI base unit? SI base unit, you need the table. Yes, yeah, here's the table. Compare the table. Ampere we have, kilogram we have, seconds also we have. This is actually coulomb, coulomb for charge. This is not in the SI base system. Okay, this is coulomb, which is not a SI base unit. What is the best estimate of the number of atoms in a piece of metal of volume 50 centimeter cube? For this, just you must have a rough idea about density and the mass number or the atomic weight of 2-3 elements. Just have a rough idea about these 2 or 3 elements, or at least one element. Here I have given 2 examples. For example, here the volume is 50 centimeter cube. So I'm going to use density from this expression, density is equal to mass over volume. I'm going to find the mass of mercury. The sample what I have taken here is mercury. So here, for the given volume, I'm going to find what would be the mass. So 50 centimeter cube. We know the density of mercury is actually 13,500 kilogram per meter cube. But here, the volume is given in centimeter cube. So I have converted that into gram per centimeter cube, which is 13.5 gram per centimeter cube. Okay. So if you multiply this, you get the mass of mercury within 50 centimeter cube of volume is 675. Then we have one more formula from chemistry. You have to take this one. Before that, you must know the atomic weight or the mass number of mercury, which is 200 or 201. Also, you can approximate to 201. Okay, so here, this is the formula. Okay, number of atoms is equal to the mass of the element times Avogadro number divided by atomic weight. So here, if you do that one, so if you see it is 675 times this, we are getting 2.0 times 10 to the power of 24 atoms. You can also check for one more element, like for iron. If you check, we are getting the same calculation. You go by the same calculation, except you change the density of iron and you replace the atomic weight. Here, that's it. If you do that one, so 394 is the mass, and this 2 things you change, and you get 4.24 times 10 to the power of 24. So we have a rough idea that it should be of the order of 10 to the power of 24 atoms in 50 centimeter cube. In 50 centimeter cube. So here the closest one is B. Okay, so the next one is a stone sinks in water. What's the possible value for the density of the stone? We all know density of water is equal to 1000 kilogram per meter cube, or 1 times 10 to the power of 3 kilogram per meter cube. Now, something is sinking in water. When it sinks in water, obviously the stone is having a greater density. Okay, stone density is greater than water. That's why it sinks. So which would be the right option? Definitely not C and D. Why? Because the unit is not correct. How about A? A is just 800. Okay, be careful. Just because this shows 8 and don't just circle A. It is only 800 if you write it in full form, 800 kilogram per meter cube. So this is not the correct option. So the option is B. This is 2000. So 2000 kilogram per meter cube is greater than 1000 kilogram. That's why it sinks. Okay. Okay. The next one, gigameter, terameter, micrometer, and picometer are all units of length. Which unit is the largest and which unit is the smallest? So you have to recall this table. It starts from tera, is the biggest one we have in A level, and the smallest one is pico. So option D. Okay, the largest is terameter, and the smallest is pico. Okay. What must be included in a record of a physical quantity? So whenever you're recording something, what is the first thing you must record? Do you think it must be an integer value? Not necessary. Do you think only we need an SI unit? Only with the SI unit, what calculations are you going to do? Nothing. It must be a numerical value. What is the last one? A unit expressed in base unit, not necessary. We are expressing quantities in Newton, in degree C. So they are not base quantities. Sorry, they are not base units. So the option here is it must be a numerical value. It could be in the form of decimal or it could be in the form of a whole number. But at least whenever you're recording, you must have a numerical value. So the option for this question is C. What is the ohm expressed in SI base units? Okay, students find difficulty with this type of question. Ohm should be expressed in base units. Ohm is the unit for resistance. Now, resistance is V over I. Voltage, okay, voltage divided by current. But here you write only in the unit form. Ohm is volt by ampere. Again, volt is what? Volt is joule per coulomb. Yeah, 1 volt. The definition of 1 volt is joule per coulomb. Work done. Actually, if you write this one, this is in the form of formula is work done or energy divided by charge. Again, what is charge? What is coulomb? Okay, so joule is work done. So work done, joule is not a SI base unit. So joule, again, you have to split that into base unit. From where did joule come from? Joule is work done. Work done is what? Force times distance. And what is charge? Current times time. Are they all in base units? Distance is in base unit. Okay, if you want to represent distance in the form of S. Okay, in A level, we represent it by S. Okay, force times distance or displacement, S. Okay, force times distance divided by current times time. Current is a base unit. Time is a base unit. Distance, which is going to be in meter, that is also a base unit. Force is not a base unit. Now, again, you have to split force into base unit. How can you define force in the form of base unit? Force is equal to F equal to MA. F equal to MA. Okay, so putting all this together, where mass is a base unit, acceleration is going to be meter ms minus 2. That's all in base unit. So now we have our formula. So ohm, all these things only the numerator. I'm dealing only with volt. Okay, this is numerator. Still, we have our denominator, so don't forget. So I'm going to the next page, so here my ohm is going to be volt divided by ampere, and our volt is force times, that is kilogram, because force is equal to MA. Actually, let me write the full form. It is F times distance, okay? Distance, yes. We are represented by S. F times, this is only for the numerator. Then I times T, which is ampere times second. This is for the numerator divided by ampere, okay? The denominator. So this is all about volt. The whole thing on the numerator within the bracket is the volt. So here, again, force is F time, which is going to be simplified into kilogram ms minus 2. Mass times acceleration. Mass is kilogram, acceleration is ms minus 2. So kilogram ms minus 2 times, this is distance. Okay, don't confuse with this S and this S. This is distance, force times distance. Distance is in meter divided by ampere second, IT, charge, coulomb, okay, IT, current ampere times second. So that is for volt. Coming to the denominator, which is ohm is equal to V by I, okay. R is equal to V by I. Ohm is equal to voltage by ampere. So voltage by ampere, it's A. Now, if you simplify this one, you have kilogram M square S minus, I'm going to take this also on top. It's going to be S minus 3. And A, and this A will go as A minus 2. Yes or no? Yes. Okay, so the answer is A. Okay. Okay, the next question. Again, Which two units are identical when expressed in terms of SI base units? Joule per coulomb. Joule is also not a base unit. Coulomb is also not a base unit. Kilogram. So obviously we are not going to check the other one. Two must be base unit. The next one. Joule second. Again, joule is not. Okay. Which two units are identical when expressed in SI base unit? I'm sorry. Okay, let us check. When they are expressed in SI based, I think joule second. Joule second, we just saw what is joule. Joule is force times distance. Yeah, force times distance. I write it in full form. So which is going to be force is kilogram ms minus 2, mass times acceleration, times distance, another meter. So joule is going to be kilogram m square s minus 2, then again one more s. So s minus 2 times s, which is going to give you kilogram m square s minus 1. This I'm doing for option B. Okay, s minus s. And what is the other one? Yeah, it's same, the other one. You see the other option? Joule second. This is joule second. This is joule second, which is equal to kilogram m square. So I think B. Okay, you can check for the other one. Definitely they are not going to, for example, if we take C, Newton meter. Newton is force, is the unit for force, which is going to be kilogram ms. I'm doing for option C. Kilogram ms minus 2 times meter, which is giving us kilogram m square s minus 2. So, but the other one is kilogram m cube s minus 2. Okay, so C is not the correct option. So like that, if you check, the only option here, which is coinciding with the first one and the second one, is B. So the correct option here is B. Okay. What is a reasonable estimate? Again, estimation. So you remember I showed an example, like cross-sectional area of 4.1 times 10 to the power of minus 7 is the cross-sectional area of a wire. Okay, of a wire. So here the cross-sectional area of a paper clip could be of the order of 8 times 10 to the power of minus 7. Okay, it's not, this is high value. This is also not coinciding with the thin wire cross-sectional area. This is also not, this is very low, like it's strand of hair or something else can be in the order of 10 to the power of minus 9. So here the correct option is C. One more estimation question. Which estimate is reasonable? Which estimate? Definitely not a grain of sand. A grain of sand, which is going to be nanogram or even less than that. Okay, so what about this one? Volume of a tennis ball? No. Just if you remember the diver's volume was given in the order of 10 to the power of minus 2. You remember for the previous slide. So this is volume of a person, okay, for an average person. 10 to the power of minus 2 is volume of of a person, of an average person. Average person. Sorry. How about C? So it's not option B. 1 joule for the work done, lifting an apple from a waist head to head height. Okay, what is the work done? Work done is force times distance. So force of, that means weight of apple would be, so say for example, if an apple is of 100 grams, so which is 0.1 kilogram. So the weight is going to be, this is mass. So weight is going to be 0.1 times, like roughly 10. Let us take this as 10 Newton per kilogram. Then it's going to be 1 Newton. So 1 Newton times distance from waist to head. Roughly, maximum it could be 1 meter. Okay, even if it is the tallest person. So it could be 1 meter. So the answer what we are getting is 1 joule. Yeah, so option C would be the correct. What is D? D says for the power of a light bulb in a house. Light bulb in a house is, are we using 10,000 watts? No. Okay, so this is not the right option. So the option here is C. Which estimate is reasonable? One more estimation question. Oh, okay. Already, yeah. That's the same thing. Okay. So the next question is, Which quantity is not an SI base unit? Which is not an SI base unit. So use this table. So here we go for charge is not an SI base unit. Here, the option B, C, D are SI base units. These three are SI base units. Okay, the next one. What could not be a measurement of physical quantity? You remember physical quantity means a number with a unit. Number with a unit. So this is a physical quantity. Okay, so we want which could not be. The last one also a number with the unit. So this option. Now let us take B and C. First I'm taking B. B is joule per Newton per meter, which means joule is nothing but Newton meter. Okay, no need to go for base. No, Newton meter and multiplied by per Newton per meter. Joule is Newton meter. Joule is force times distance. Force is Newton, distance is meter. So Newton meter. So Newton will get cancelled. Meter and per meter will get cancelled. So again, we are left only with 11. So this option is correct because it has no unit. It has only a number 11. Let us check this one. See, Pascal, meter cube per Newton. Pascal is unit for pressure. Newton per meter square. Meter cube per Newton. So Newton and Newton will get cancelled. We are left with m cube m minus 2, which is n. Okay, so we have a unit finally. So it is a physical quantity. So option C is not the answer for this question. So the one is B, which has no unit left behind. Which pair of quantities are physical quantities? Remember the table? Do we have the table here? Okay, note it. Charge and ampere. Charge is not a physical charge. Yeah, charge is a physical quantity. Ampere, current, it is a physical quantity. But physical quantity, it is a unit. Ampere is a unit. Charge, efficiency is not a physical quantity. Kilogram is a unit. Okay. Then Pascal for pressure. Okay, it is a unit. It is not a physical quantity. Strain is a physical quantity. Period is a physical quantity. Potential difference is a physical quantity. So option D. Okay. A computer memory stick is labeled as having a storage capacity of 128 gigabytes. The letter B stands for byte, which is a unit. What is the equivalent storage capacity? Okay, so use this table. Gigabyte is 10 to the power of 9 bytes. So here 128 times 10 to the power of 9 bytes. If you write the gigabytes in the form of bytes, it's going to be 128 10 times 10 to the power of 9 bytes. This is not in scientific form. If you write it in scientific form, it's going to be 1.28 times 10 to the power of 11 bytes. So here the option B is the right answer. Okay, the next one. Which list of unit prefixes decreases in magnitude from left to right? Okay, so you must start from the highest. Yes or no? From the highest. Centi, deci, no. Decrease in magnitude from left to right. Deci, milli, centi. Shall we have the table? Yeah. Yeah. Look. Centi, deci, milli, no. Deci, milli, centi, no. Okay. Pico, kilo, milli, no. Kilo, milli, yeah, starts from the highest. Kilo is the highest. Then it goes to milli. Then it goes to pico. Yeah, so this one. Okay. What is the symbol for the SI base unit of temperature? It is not C. It is K. Okay. Degree Celsius is not a SI unit. So, and students often refer K as degree Kelvin, which is also wrong. Okay. So it is only just Kelvin, K, capital K. Okay. That's it. We came to the end of the video. Thanks for watching. Please like, share, and subscribe for more videos. Thank you. Bye.